Hello, good to see you again. Welcome to Block 2, Solving Problems with Multiplication and Division. Lesson 3. I'll share my screen. So, in your previous lesson, you learned how to understand factors and how to use factors to solve different problems, including finding common factors of pairs of numbers and finding the highest common factors of those pairs of numbers. In today's lesson, you're going to learn to understand and use multiples. But before we begin, I want to appeal to you, like the video, share it with friends and those you think can benefit. Subscribe to the channel, click on the notification bell so that when new videos are uploaded, you'll be notified. Thank you for helping us grow our mission to educate the global population of children who may not have the financial resources to pay for high quality maths education. Thank you. Before we start, I would like you to answer the retrieval practice questions in 4 minutes. Assuming you've paused the video and you've answered the questions, here are the answers. So for the first one, you were asked, what is 6 multiplied by 4? It's 24. What multiplication facts, question 2, does the diagram represent? The diagram represents 8 times 5, which is equal to 40, or 5 times 8, which is equal to 40. Question 3, you were asked, write down all of the factors of 18. All of the factors of 18, you could have written them as factor pairs, or you could have listed them. Next, you're asked, work out the next two terms in the sequence. I'm sure you would have noticed that that is the 7 times table. So to complete the times table, you could add 7 to 21 and 7 to 28. All right, let's do some new learning. We're going to talk about multiples. Now, multiple, I want you to understand multiple as the product of two numbers, okay? Product of two numbers. Now, but those two numbers could vary, all right? Now, here, check this out. 32, if we want to write this, complete this statement, we'll say, well, 32 is a multiple of 8. It means that 8 times another number will give us 32. What about this? If we add an extra 8, what can we say about 32? Has it changed anything? Not really. It's just the number has just changed, but it's still a multiple of 8. So we can say 40 is a multiple of 8. What about this one? Has it changed anything? Not really. It's just the same, telling us that 16 is a multiple of 8. So you may be wondering, what's going on here? What have we noticed? Well, we're noticing that the number that we say is a multiple of another number is actually in the times table of that number. So regardless of how much we change this, we'll say, oh, well, it looks like 4 times any other number will give us 16. So 16 is a multiple of 4 because 16 is in the 4 times table. Here, 16 is in the 2 times table. So we'll say 16 is a multiple of 2. 16 is in the 1 times table because 1 times 16 is 16. So we say 16 is a multiple of 1. And then 16 is in the 16 times table. So we say 16 is a multiple of 16. All right. All right. So you get the idea, right? Can you complete this sentence? Pause, have a think, and see whether you can complete this sentence. All right. Of course, we can say 27 is in the 9 times table. So 27 is a multiple of 9. All right. I want you to write down the first 5 multiples of 9. Okay, so you get the idea. So I'm asking you, it's another way of asking you to write the 9 times table, but to write the first 5 numbers in the 9 times table. All right, assuming you've done that, here are the answers. Okay, you get the idea. Interesting. But when you're asked to answer questions about multiples, sometimes you may be asked the question slightly differently. So it's very important that you pay attention to what you asked to do. So here, the question has not asked us to write the first 5 multiples of these numbers. It's just asked us to write any 5 multiples. So here we go. Pause the video and see how many you can write. And here we go. Here are the answers. Okay. Have you noticed that we've made a jump to write multiples that are not really close by the first ones? So we've just written any multiples. And of course, these are multiples of these numbers 18 and 200. Okay, here is one final example. Sometimes the questions could be varied. We just need to be a little bit clever. Having understood how multiples work, we can be a bit clever to answer questions. Now, for example, if we're asked to write down a multiple of 6 greater than 100, are you going to start writing the 6 times table until you find that number? That won't be a clever way to do it. We could do it like this. We could say, well, let's use a number line to do it. We say, well, we know that 6 times 10 will be 60. All right. And we could think, okay, what other number is a multiple of 6? We know is 30. So we say, okay, I can make a jump from 60 to that number to get closer to 100, which is 90. So 90 is definitely a multiple of 6. And then we can say, okay, what if we add 6 to 90? That gets us closer to 100. And if we add another 6 to 96, that gets us to 102, which is greater than 100. Now we can make a generalization to say, okay, any number more than 102 definitely answers the question that we were asked. So we can say, well, 102 plus 6 times whatever number will give us, yeah? So the n means any number. So 102 plus 6 times 1 will take us to the next number. 102 plus 6 times 2 will take us to the next number, which is obviously greater than 100. Okay, pause the video and answer questions 1, 2, 3. Pause the video and answer questions 1 and 2 in 3 minutes. All right, assuming you've paused the video and you've answered questions 1 and 2, here are the answers. So here you were asked, explain how the bar model shows that 35 is a multiple of 7. Of course, we can see it shows that 5 times 7 is 35. Remember what we said? A multiple is simply the product of any 2 numbers. Okay. Here, find the 3 more multiples of 7. Okay, there are more. You can see them there. And then find a multiple of 7 greater than 1,000. You can just list any multiple. Okay, and then here, draw a bar model to illustrate why 48 is a multiple of 8. Okay, just draw a bar model of 48 showing 8. Okay, 6 lots of 8. And that will be equivalent to, give us the answer. Okay, pause the video and answer question 3 in 2 minutes. All right, so we now know that when you talk about multiples, we're talking about the times table of that number. So here we're asked to find any 5 multiples of these numbers. So we could have just multiplied 5 by any number and write the number, 11 times any number, and then 17 times any number, and then we write our numbers. Okay, Sometimes we find interesting thing about multiples which takes us a bit further to deepen our learning just the way we did with factors. If we were asked to list out the multiples of these two numbers on this 100 grid, the multiples of 6, if we were to square them, we'll get this. Of course, you notice a pattern. So for every 6 steps, we get to the multiple of 6. You can see it there. 1, 2, 3, 4, 5, 6. If we circle the multiples of 8, you will also notice another pattern. But something interesting is that there are some numbers that are also circled and also colored in green. That is what we call common multiples, right? So can we complete this statement now? Of course we can. We can say that these numbers, you can see the numbers that are circled and also in green, we can write them here. They are all common multiples of 6 and 8. But we can take it a bit further. Sometimes we get asked to find the lowest common multiples of numbers. So that is when we now look at these numbers and we say, well, which is the lowest one? Which is sometimes you hear people say LCM. Okay, when we were learning about factors, highest common factor is HCF. So now we're learning about common multiples, so which is LCM, and then that gives us 24, and that's our answer. Okay, let's do another learning, another example. Here, let's call him Charles. He says to find the LCM of two numbers, you multiply them together. Well, he's made a very strong generalization, but let's test it. Would it work here? 7 and 6? Well, let's write out the multiples of 7 and then the multiples of 6, and then let's find the lowest common multiple, and then we multiply the two numbers 7 and 6 and see whether they are the same. Well, it seems to work, right? Because 7 times 6 is 42. Okay? But here, 4 and 10, we see that for the multiples of 4 and the multiples of 10, the lowest common multiple is 20. So it doesn't quite work because 4 times 10 is 40. So it means Charles is not right. It does not always work. So here is some for you to try. Which ones do you think will match Ron's method? Which ones do you think would work for Ron's method, where if we just multiply the numbers, we'll get the lowest common multiple? Have a think. Of course, there are these numbers, okay? 15 and 16, and then 8 and 11. So take note, a learning point here is multiplying the two numbers that you're given to find the lowest common multiple of doesn't always work to give us the lowest common multiple. So be careful. It's now time for you to practice these questions in 3 minutes. So pause the video and answer question 4 in 3 minutes. Assuming you've paused the video, here are the answers. So here you were asked to circle all of the multiples of 12, draw a square around all the multiples of 8, and then list all the common multiples of 12 and 8, and then find the lowest common multiple. So celebrate your success, mark your work. All right, pause the video and answer questions 5 and 6 in 3 minutes. Okay, assuming you've paused the video and you've answered questions 5 and 6, here are the answers. Let's discuss them. So here you were simply asked to find the lowest common multiple of these numbers. So you use the same method we used before. You list the multiples and then you find the lowest multiple that is common to both of them. Okay. And then here you were asked, tick all the multiples of 30. Okay. So multiples of 30 will be the numbers that you think you would find in the 30 times table, or the numbers you think you would get if you were to multiply another number with 30. Or another way of thinking about it, a quicker way would be to check whether you will be able to divide these numbers by 30. So if you get whole numbers, it means they are multiples of those numbers. 30 those numbers are multiples of 30. All right, pause the video and answer questions 7 and 8 in 2 minutes. All right, assuming you've paused the video, here are the answers. So 495 is a multiple of 15. Find the first three multiples of 15 above 500. Well, a quicker way to do it would just be to add 15 to 495, and then you generate more numbers from there. And then here, we agree with both of them, okay? 6 is a multiple of 6. Why? 6 is in the 6 times table. Yeah, 6 times 1 is 6. 6 is a factor of 6. Why? Remember what we said about factors? Okay. So 6 is a factor of 6. Because if we were to find the factor pairs of 6, we'll see that 6 times 1 is 6. All right. Pause the video and answer questions 9 and 10 in 2 minutes. You can take longer. You don't have to rush. Take your time to learn properly. All right, assuming you've paused the video and you've answered the questions, here are the answers. So mark your work and celebrate your success. All right. Here you ask the last one, what is the lowest common multiple of 3, 5, and 20? So you list the multiples of 3, you list the multiples of 5, you list the multiples of 20, and then you find the lowest number that is common to all of them. Okay. That brings us to the end of our lesson. So what have we learned so far? We have learned that multiples are simply the product of two numbers. And to find multiples, you can simply think about your times table. You have to have really good knowledge of your multiplication tables to think about multiples. And then you made progress to find common multiples of more than one number. And then after that, you then made progress to find the lowest common multiple of the list of those common multiples. All right. Until next time, well done for sticking around. Take really good care of yourself. Bye-bye.